This is the polar question from the 2014 exam. The first thing we have is r equals 3, that's your circle. So this graph right here. The next one is the cardioid, which is right here. Well, it's not quite a cardioid, but very similar, and that's this graph. So they want us to find the common area. So looking at that, remember you want to cut your theta wedges. So when we first cut our theta wedges, we're going to want to go to the blue graph. And we're going to keep cutting our theta wedges until pi over 2. So the area for that one would be 1/2 the integral 0 pi over 2 3 minus 2 sine 2 theta, square that, d theta. And then at pi over 2, we're going to switch curves and we're going to now be cutting to the circle. And we're going to do that from 1/2 from pi over 2 to pi of the circle. And then we put that in our calculator and we get both of those added together is 9.708. Make sure that you're in radians, but you can keep your calculator in the XYs. Part B, we want to find dx d theta for theta equals pi over 6. So we know that x is the same thing as r cosine theta, and for us, r is 3 minus 2 sine 2 theta times cosine theta. Now this is a calculator problem, so you can feel free to use your calculators. So I'm going to go ahead and take the derivative. The derivative of the first piece would be minus 4, because chain rule, we had the 2 coming out, so minus 4 cosine 2 theta, copy down the second one, plus the derivative of the second one, copy down the first. And we're going to evaluate this all at pi over 6. And when we do that, we get negative 2.366. You do not need to show the derivative step, but you must show what x is equal to and say dx d theta is equal to, at pi over 6 is equal to that. So part C, the distance between the two curves is changing between 0 and pi over 2. Find the rate at which the distance are changing when the two curves are at pi over 3. So the distance between the two curves is going to be the big curve minus the little curve. So for us, 3 minus 2 sine 2 theta. So the distance between the two curves are 2 sine 2 theta. So we're going to take the derivative of this to see how they're changing. So that would be 4 cosine 2 theta. And we're evaluating this at pi over 6. And that works out to be negative 2. So what does that mean in terms of the curve? This means that the distance between the two curves is decreasing and they're getting closer together. It did not ask us to interpret it, but we definitely can. Part D, a particle is moving along the cardioid such that d theta dt is equal to 0. Find the value of dr dt. Okay, well, looking at our r, 3 minus 2 sine 2 theta, they want us to find dr dt, but if you notice that r is a function of theta, so we can only find dr d theta, then multiply it by d theta dt. They told us that d theta dt at that given time is 3, so we know this right here is 3. And we can find dr d theta by taking the derivative of the r, so that's going to be equal to minus 4 cosine 2 theta times 3, and we're going to find this value at pi over 6 again, and that works out to be negative 6, which would mean that the curve is moving closer to the origin. And how is this scored? The first part is worth 3 points. You get 1 for the integrands, 1 for the limits, and 1 for the answer. Now, Notice we didn't have to do this as an integral. I know that was 1/4 of a circle, so I could just use the circle formulas. Part B is worth 2 points. 1 is for the expression in x, and 1 is for finding the value. For C, the first point comes from the equation for distance, and then taking the derivative and evaluating it. And then the last one, you get 1 point for noticing that you had to do dr d theta multiplied by d theta dt, and then 1 point for the answer. This one did not ask us to interpret any of those values, but remember we can.